Let's talk about LeetCode 780 reaching point. They give us a start point SX and SY in the target point TX and TY. In the both have the range from 1 to 10 to the power 9 range. And we have two options of operation is that we can have X in the this point XY can convert to X plus Y or X plus Y, right? So trying to see if this start point can reach end point. Uh, Intuitively, what we're thinking about is that we just do DFS, right? The start X, start Y, right? They have two branches, SX plus SY and SY, right? Another one is SX and SY, SX plus SY, right? Then it have another two branches, another branches until whether we can hit TX or TY, right? But doing like this way, we'll see it will be expand, right? So it will for one point, it's going to extend to 2 points. In every 2 points, it will have another two children. So in the end, it will be 2 to the power a lot um, points, right? And trying to check if it is the TX and TY exists in this kind of points. Apparently, it will TLE or auto memory. But we can consider reversely that whether we can do from TX and TY, trying to see if they are able to go backwards to SX, XY, right? So backwards is that it can have TX minus TY, right? And TY, or TX, TX minus TY minus TX, right? So there are two options. But the thing is that so we may be questioned. There are also still two options. What's the differences? The difference is that we don't actually go to two options. If Tx is greater than Ty, right? Apparently, we cannot go this path, right? So we can only the previous step can only be Tx minus Ty and Ty, right? Otherwise, this is a negative number, right? So the previous step is only one, right? So the things that it will be a shrinking step, and also doing backwards checking. Let's see, it's not a one child, one node go to multiple, but the parent is still one, right? So this is the advantage. But doing like this way, check step by step, it is still a lot of calculations. For example, if Ty equals 1 and Tx equals 10 to the power 9, right? So we still need 10 to the power 9 operations. Apparently, that will still be TLE. So how can we do efficient? What we can thinking is that as long as the Tx is greater than Ty, right, we can keep in minus, right? For example, we minus m multiplied by Ty, then this one gets smaller, right? So this operation is equivalent as Tx mod Ty, right? So the thing is that if Tx is greater than Ty, instead we use keeping minus operations, we just use a mod operation. So that we can get rid of all of the minus TDS minus operation, right? Just use one operation. And else if the Tx is smaller than Ty, right? So we just use the Ty mod Tx, right? So in the end, for our while loop is that while our Sx is smaller than Sy, and Ty, right? Tx and Sy is smaller than Ty, right? So when we jumping out of this while loop, we will have at least one of the operations that Sx equals Tx or Sy equals Ty, right? So if Sx equals Tx, then we just need to check if Ty plus mTx equals Ty, right? Sy plus mSx equals Ty, right? So that is, we just need to check if this diff mod the the mod Sx is zero, right? So the same thing, if Sy equals Tx, so that means we have Xx plus mod some kind of number of Sy equals Tx, right? So we just need to check if this diff mod this one is zero, right? So let's write code for this. So we can write while Sx smaller than Tx and Sy smaller than Ty. So we'll do if Tx is greater than Ty, then we just have Tx mod equal to Ty. Else, just have Ty mod equal to Tx, right? So when we're jumping out of this while loop, we all have either return, right? Return Sx equals Tx, and the we need a Ty minus Sy mod Sx equals zero, right? So that means we align Sx. This one already equals, right? But the thing is, we want to Sy plus m multiplied by Sx equals Ty, right? So we just need to make sure this one is mod this one equal to zero, right? So or we need to have an or condition is that we already have the Sy equals Ty and Tx minus Sx mod Sy equals zero, right? So this will be the when we are jumping out of the while loop, we need what we need to check. Mm. Sy equals Ty and we should have another condition, and this is not enough yet, and Sy should smaller equal to Ty, right? So here that we should Sx smaller equal to tx. Use this one. So let's look at why this condition why we need this condition, right? So let's see. Um, the S if we don't have this condition, we can just have initial check that we need the ty greater equal to sy and tx greater equal to sx, right? So if this is smaller, of course, we'll uh, return false, right? So this if we don't have this condition, right? So it is possible that ty smaller than sy, right? So of course, if we don't have this, we can do check first, right? So that will be more straightforward. So if sx greater than tx or sy greater than ty, just return false, right? Doing like this, the time complexity will be the log operations because this is we are keeping use a smaller ones, smaller parts. So it will be a log max x tx and then ty. Space complexity will be O1. Um, Python code is very similar. So let's say if sx greater than stx or sy greater than ty, right? That's a return false. So we are doing the while loop while sx smaller than the just the case for, right? The tx or t greater than t sx greater than tx. The while loop doesn't go through the while loop even, right? While this one smaller than tx and sy smaller than ty. So what we do is if tx is greater than ty, so we'll have tx mod equal to ty, else ty mod equal to tx, right? So in the end, we just need to return sx equals tx and ty minus so we know sy plus m sx equals ty, right? So ty minus sy mod sx equals 0, right? Um, or oh, we can have a slash here. Slash O sy equals ty, and tx minus sx should be divisible by sy, right? This one here. Mm, should have all here. Expect character. Let's see. Yeah. Okay.